Okay, problem 35 is sketching a exponential function, which we've already done this before, but we'll go through this again. So just like I made a chart in school on x and I put all the x values, I chose some values of x, and then our function is f of x, which is your y value, is 6 to the x. So I have negative 2 put in for x here, so that's 6 to the minus 2, which is 1/36. So 1 over 36 is our value here, and if I put negative 1 in here, it jumps up to 1/6, and 0, we go all the way up to 1, and for 1 we're jumping up to 6, and for 2 we're already up to 36. So you can see how these things go very fast from 1/36 all the way up to 36. So if I went to put these on the graph and move these points that I have here, negative 2, let's say that's negative 2, 1/36. My points are kind of fat here, so we'll move them. And negative 1, 1/6 already. If that's 1/36, 1/6, it's a little higher. If I can get it where I want it. Okay, then 0 goes all the way up to 1. I'm not doing these exactly. Then you get 1 goes up to 6. And then 2 goes all the way somewhere up here to 36, like way out in space here. Now you'll notice that this curve will come down here and it will closely get to this x-axis but never touch it. Now you're supposed to verify this graph once you draw. I'm not going to draw a line in there because I've already verified the graph on the calculator. So once you verify this with your calculator, you should come up with this when you chart it. You'll notice, see how it goes down there very close, but it will never cross the x-axis. Okay, now the next one, we have a logarithm, so you can see what a logarithm will look like. Choose some points. Think about this. 4 is being raised to some power to equal the x. That's really what's going to happen here. So to get this, you're going to choose some values of x. Choose some values of x that you know 4 can be raised to. Okay, so if I want x to be 1, what am I going to raise 4 to? I'm going to raise 4 to the 0 power. 4 raised to the 0 power will equal 1. 4 raised to the first is equal to 4. So the 4 goes here, but the first goes over here. You see, 4 is our base. It's being raised to the first power will get us 4 in the log. It's a little backwards. Okay, so if you want to think about it, if you put it in here and I say 4 raised to the second power will give me 16 for my x, you can see that these are going pretty fast. And so what you really want to see is what happens when I raise it to the negative power. Well, 4 raised to the minus 1 gives us 1/4. Okay, and so I've got 4 points here. I'm going to go ahead and see if we can see where they are. Okay, so I have the point 1, 0. Let's say that's there. 4, 1 looks like about here. 16 only gets up to 2, so way out here at 16 we're up here about 2. If I want to go over here this far, we're about there for that point, and 1/4 -1. So just at 1/4 we're already at -1. So now you can see what this graph is doing. This graph comes up here like this. Will it ever touch that y-axis? Well, once you graph it on your calculator and you got to realize that how can I get 0 here? What's going to give me 0 for a y, which is f of x? Okay, how can I get that to be 0? Well, here it is. There's what the graph looks like. And that's what the graph of a logarithm. This is base 4. And as you can see, it comes right down here and keeps going.